Hey everyone, and welcome to this explainer, Extreme Engineering, powering a boat with an airplane engine. Today, we're tracking an absolutely wild engineering journey. Have you ever tried to build something incredibly powerful, only to be held back by the very technology that's supposed to fuel it? It's a classic problem. Well, we're looking at a massive DIY build that attempts to solve some really severe electric battery limitations using pure, unadulterated petrol power. We're going to walk through how an ambitious creator went from wrestling with dying batteries to literally harnessing the thrust of an actual airplane engine. Let's dive right in.
So what happens when electric motors just aren't enough? To really appreciate this pivot, we have to understand the core dilemma of these high-powered DIY builds. It's usually not a lack of rotational force, right? It's the intense frustration of incredibly short runtimes and just agonizingly long charging waits. I mean, when you're testing heavy-duty machinery, having your power source die after just a few minutes of flight time is a massive bottleneck. You do one quick test flight, the battery completely discharges, and boom, you're stuck waiting hours just to try again. It completely stalls the creative and engineering process.
100cc brushless motor versus a petrol airplane engine. Now, the creators were originally working with this massive 100cc brushless electric motor. And make no mistake, this is an incredibly powerful piece of hardware. It's got a massive propeller, and to put that into perspective, the creator noted that combining just 4 of these could easily lift a heavy person. Just 2 of them? That's enough thrust to fly a large airplane. In fact, the electric motor's sheer torque is so dangerous that during a previous test, a crew member named Manish narrowly escaped serious injury. But despite all that crazy power, its heavy reliance on rapidly draining batteries makes sustained testing almost impossible. You can have all the thrust in the world, but if your battery dies in 3 minutes, it's virtually useless for prolonged outdoor testing.
Looking at the specs here, we're talking about a 3-kilogram weight, a petrol power source, and key components like twin spark plugs, an air intake, and dual exhausts. To solve that battery drain once and for all, the creator just totally ditched the electric route and imported a highly specialized petrol-powered airplane engine. The shipping actually took so long that some of the packaging rubber melted and stuck to the engine. But what's truly incredible here is the engineering efficiency. It delivers heavy-duty airplane thrust while weighing a mere 3 kilograms. It comes fully equipped with the air intake, dual exhausts where the silencers attach, and a super reliable twin spark plug system, one on each side. It is basically a compact little beast of combustion-based power. Just 7 volts for ignition. Okay, there is a slight bit of irony here, right? Actually, scratch that, it's pretty funny. The whole point of buying this petrol engine was to escape the curse of the electric battery. Well, it turns out even this petrol engine isn't entirely free of electricity. Because of that sophisticated twin spark plug setup we just talked about, the engine still requires a small 7-volt 2-cell battery just to spark the ignition system. So while the propulsion itself is driven by limitless petrol, you still absolutely need that tiny electrical jumpstart to bring the whole shebang to life.
Step 1. Mount the engine. Step 2. Install servos and fuel tank. And Step 3. Configure the receiver and throttling. Of course, harnessing this kind of raw, combustible power wasn't just a simple plug-and-play operation. It required intense calibration. First, they rigged up a test bench. They actually had to mount the engine upside down compared to its normal orientation. Then came the tricky part, installing servo motors to physically pull the mechanical throttle, piping in a petrol tank, and meticulously configuring the remote control's really complex throttling settings. Fine-tuning these functions? Yeah, that required an exhausting all-night session just to get the engine to idle properly without stalling out or redlining.
Bro, the thrust is so strong, I had to lie down. Well, that grueling overnight setup totally paid off with an absolutely terrifying bench test the next morning. Because they were firing it up for the very first time, they literally didn't even know if the propeller would spin clockwise or counterclockwise, forcing them to conduct the test outdoors just for pure safety. And man, when they finally flicked the ignition and opened the throttle, the engine unleashed this deafening roar. The thrust generated was so overwhelmingly strong that it physically dragged the heavy test rig forward. The pull was so intense, the creator literally had to lie flat on the ground just to hold the engine back from flying away.
So where exactly do you mount a tuned airplane engine? With the engine fully calibrated, tested, and proving to be an absolute powerhouse, it was time for the ultimate proof of concept. The answer? On water. They decided to revive a custom missile boat they had built previously. Now, this specific boat was completely plagued by the exact electric battery failures we discussed earlier. It had a powerful electric setup before, but the batteries just kept dying out on the water. And trust me, no one wants to paddle a heavy boat back to shore just to plug it into a charger. Replacing that completely unreliable electric setup with this finely tuned petrol engine was the perfect extreme upgrade.
We are talking unlimited runtime with petrol fuel, fully functional remote control steering, and manual driving capability with onboard seating. Out on the lake, this petrol solution proved to be a massive success. First and foremost, they finally achieved unlimited runtime. As long as you can pour petrol into the tank, you have relentless, high-speed thrust. No more waiting around for chargers. Second, despite the complex mechanical throttle, they successfully mapped it to a fully functional remote control. This allowed them to steer the boat's rudders and control the airplane engine speed right from the shore. But they didn't stop there. They also engineered manual driving capabilities. One of the team members, Balvier, was actually able to sit on board the boat and drive this roaring airplane engine-powered vessel completely manually across the water. It was a massive win for backyard engineering.
So, what should this engine power next? Having successfully conquered the water, the team entirely eliminated the electric battery dilemma that had held back all their previous projects. They took a technology meant for the skies, adapted its intricate mechanical and electrical systems, and built an unstoppable watercraft. It's like putting a rocket on a surfboard. But this whole success leaves us pondering the broader implications of DIY engineering. As batteries get better and better, will extreme petrol builds like this become a thing of the past? Or will the raw, limitless thrust of an airplane engine always hold the crown in backyard engineering? Let me know what you think. Thank you so much for joining me for this explainer.